Alright, so in this video I'm going to be discussing transformers. So essentially the function of a transformer is to decrease the amount of current that's getting to an electronic device. So when we run current from like a power plant all the way to your house, we're decreasing the current as it makes its way there so that it's at some reasonable voltage and some reasonable current in order to, power the electronics in your home. So a transformer uses Faraday's law, and you essentially have two different circuits. So the first side is called the primary, and then you have it attached to a iron ring like this, or some sort of, we're essentially making an electromagnet. So let me just draw. So this is like an iron loop, right? And so over here you've got the wire of the initial primary voltage source, and it loops around one side, and as a result we know that that is going to create a magnetic field, right? By looping these, that's an electromagnetic, so there's a magnetic field in here, and then over here I have another set of loops, and this is attached to some circuit here. And so as this thing is turning sort of on and off, we're changing the magnetic field. So this is probably an alternating current situation. And so we're creating a changing magnetic field, which then induces a current on this wire by creating some sort of voltage. And so this is called the secondary. All right, so the point is that we want to decrease the current. So some of the principles that apply is that according to the laws of conservation of energy, the power input by this has to be equal to the power out over here, right? Now, we know that to calculate power, it's I times V. So you've got the current of the primary up here, times the volts of the primary is going to be equal to the current in the secondary times the current, or the volt in the secondary, right? So how does this effectively decrease current over here? Well, according to Faraday's law, if we remember, voltage was dependent on the change in the magnetic field over time, but also it had to do with the number of loops. So by effectively decreasing the number of loops over here, we can change the voltage from the primary to the secondary, causing the current to either go up or down, right, by affecting the voltage. So the ratio is that the volts of the primary is proportional to the number of loops in the primary, which is equal to the volts in the secondary, which is proportional to the number of loops in the secondary. So by changing the number of loops, we're effectively changing the amount of current that is going to be going through our secondary. So we have conserved power, but we have decreased current.